Hello, everyone. So, welcome to the other section of this lectures. So, this is chapter 2, that is descriptive statistics. Just as we've learned in chapter 1, what descriptive statistics is. So, we want to show what we mean by descriptive statistics. So, in section 2.1 and 2.2 will help us understand what descriptive statistics is. So sometimes we want to display our data. So we have three popular data displays. One of it is the stem and leaf diagrams. We have the frequency histograms and relative frequency histograms. So let's talk about the stem and leaf diagram. So what we mean by the stem and leaf diagram is that whenever you have data points, that data point will have a stem and it will have a leaf as well. So when you pick 40, for instance, then 40, the 4 is the stem and 0 is the leaf. If you pick 69, for instance, 6 is what? Is the stem and 9 is the leaf. If you pick 100, for instance, then 10 is the stem and the 0 is the leaf. So the leaf is the rightmost digit and the stem is all digits to the left, excluding the last digits. So whenever you have data points, you want to put these data points into a stem and leaf diagram. So in that, we have a line that divides the stem from the leaf. So each stem will have its corresponding leaf. If it is a single number, then there is a number that begins that single number, and that is what? 0. So for all single numbers have a stem of what? 0, and so on and so forth. So we have example of our data points here. As you can see, we have the minimum to be 1, the maximum to be 46. So you want to use 1 and 46, for instance, to demonstrate what we mean by a stem and a leaf. So 1 is a single number, and there's a number that begins 1, which is what? 0. So the 0 here will be our stem, and 1 will be the leaf. Then you use a line to divide it. And you have 46. The 4 is what? Is our stem, and the leaf is what? Is our 6. So you put all these numbers in a stem and leaf diagram. So 0 to 4 are the stems, and you have the leaves in each stem. So you do a rough sketch like this. Then you rearrange the leaves in each stem from the smallest to the highest. So when you pick 0 as a stem, its leaves were what? 6, 7, 5, 1, 5, 6. So rearrange these leaves in from smallest to highest. So we have 1, 5, 5, 6, 6, what? 7. Then this will be the correct stem and leaf plots diagram that you're having. And also, we want to display our data through frequency histograms. So we want to use bars to represent each class. So the frequency denotes the number of times the data actually occurs in our data set. So when you pick 2 and 2 occurs 6 times in our data set, then 2 will have a frequency, a height of what? A height of 6. So the frequency histograms, they are bars, whereby these bars have no separations, they have no gaps in them. So you demonstrate how to use this frequency histograms as well. So first of all, we have our frequency on the vertical axis, and we have our classes, that's the distinct values, on our x-axis, or the horizontal axis, on the horizontal axis. So the same thing applies with the relative frequency. So instead of you to use the frequency, you're going to use our relative frequency. Remember that in section 1.3, we talked about frequency and relative frequency and how to do those things. So there's an example here. We have our data points for which it has been put in a data frequency table. So we realize that these are distinct values. 1 through 6 are distinct values. So we have them on the horizontal axis, that is the x-axis, and we have the frequencies on the vertical axis. So the first diagram that you see is the frequency histograms. So each class has its own corresponding height, and these heights are represented by bars. So 1 has a height of what? 3, and so on and so forth. So you do the same. So if you want to draw a relative frequency histogram, then instead of the frequency, use the what? The relative frequency values. So 1 has a relative frequency value of 0.18, 0.18, 0.18. So you draw a bar of 0.18 for 1. Then you do same. So you are going to measure it and know how to draw the bars for each and every one of it. So we realize that we are going to use 0.1, 0.2, 0.3, 0.4, and so forth. So 0.18 will be in between 0.1 and 0.2. So one will have a bar for what? 0.18. We do save for each of the classes. Then you are done with what? The graphs. You are done with the graphs. Okay, so this is what. So these are some three popular data displays that we've seen. One is the stem and leaf diagram. We have the frequency, whereby we use the frequency histogram, whereby we use the frequency, the relative frequency histogram, whereby we use what? The relative frequency. Note that their display, how they are being displayed, will be the same. Just that for this one, the vertical axis for the frequency histogram will have the frequencies, and for the relative frequency histogram, the vertical axis will use what? The relative frequencies. Okay. So these are some kind of examples that we are seeing. What is the frequency of the value of 8? We realize that 8, how many times that 8 comes in the data? 8 appears 3 times. What is the relative frequency of the value of 8? Now, what is the proportion that 8 takes from what? This number of data sets. Since it comes in 3 times, then it takes 3 out of the 18 data points that you're having. So that is our sigma f, is what? 18. So you can put this in decimal and you're going to have 0.167. Okay. So now, sometimes you want to know how our data is being centered. We want to know the center of our data. We want to know the center of our data. How do we get the center of our data? So we have 3 measures that determine the center of our data. So we have the mean, the median, and the mode. The mean, the median, and the mode. And you are going to know the definitions of this as we move on. So for example, for the data set 1, 2, 3, we have to find the following. We have to find the sum of S. So the S are what? Are our data points. So we want to sum them. We want to sum of S. So we have 1, 2, 3. Add them. We have 1 plus 2 plus 3. Then we get what? 6. We have sum of S squared. So it implies that each S squared, each S square it and sum it. So we pick 1, we square it, we pick 2, we square it, we pick 3, we square it. Then we sum 1 squared plus 2 squared plus 3 squared. Then you're going to get 1 plus 4 plus 9. Then we have our answer. Okay. This is different from sum of S all squared. It's different from sum of S all squared. So sum of S all squared means that sum all your values of S. So 1 plus 2 plus 3. Sum them. The answer you get, you square it. It's different from sum of S all squared. It's different. So know the difference. 2a. So 2, we have 2, we have 2a. Note their difference very well. So the sum of S, we sum all our S values first, then we square it. So know how we've done it. And you have the sum of S minus 1 all squared. So here, we pick each S value, then we subtract 1 from it. So you pick 1, you subtract 1 from it. You pick 2, you subtract 1 from it. You pick 3, you subtract 1 from it. Then you square each of them. After squaring each of them, then you sum them together. So 1 minus 1 all squared plus 2 minus 1 all squared plus 3 minus 1 all squared. Then you sum them based on the symbol that we are having here. So note these differences. Go over it once more and let me know if you have any kind of question. So now we want to know where our data is being centered. So there are some measures that will determine the center of our data. So we want to know the middle part, like the center of it. Okay, so you have the sample mean, and this is denoted by S bar. So there's an S with the bar. A bar is a line, a horizontal line. That is S bar. How do we define the S bar? It is the sum of all our data points that you're having all over the total number of data points that you're having. That is the sample size. So the sample size is the same as our sigma F. So you average them all out, then you're good to go. The mean. So we have the first one is the sample mean, whereby we pick a sample of it. But when you have the population mean, we are using the whole size. We are using the whole size that you're having. So we didn't take a part of it. We are using the whole count that you're having. So that's the population size. That's the population mean. Okay. And definition of sample median. definition of sample mean. Sometimes we want to know the middle part of our data. So that's the middle part. So we use the S tilde, the middle part of our data. So before you calculate the median of your data, the first thing to do is rearrange your data from smallest to highest. Rearrange your data from smallest to highest. Rearrange your data from smallest to highest. Then now determine the middle part of your data. Where can you find the middle part of your data? So sometimes if your data points, you count them and they are even, then it implies that you're going to have two numbers in the middle. You're going to have two numbers in the middle. What you do is that sum those two numbers and divide by 2. Sum those two numbers and divide by 2. But if you count your number of data points after rearranging them from lowest to highest and they are odd, then you can locate the middle part of it. It's very simple for that one. Okay. And we want to know the definition of the sample mode. So we want to know the number in our data set that occurs the most. The number in our data set that occurs the most. So you have a data set. Which data set occurs the most? Then that data set is what? It's our mode. It's our mode. Sometimes you can have two data sets occurring the most. Then know that the mode are what? These two data points. The mode are what? These two data points. Okay. So that there's an example here, and we've calculated the mean, the median, and what? The mode. Note that the median, we use the S tilde. It's not S bang. It's not bang. It's not straight line. It's like a snake sign. S with the snake sign on top. Note that very well. And we've demonstrated how to use the calculator to calculate this without going through the stress. So if you have your TI-84 calculator, all you need is to go to the stats and go to edit. So you edit, you're going to have the list 1, list 2, list 3. Input your data points there. Then click the start again. If you click the start again, on top of it, there's a calc. So shift or click the right arrow, go to the calc and click enter. Click enter. If you click enter, then it will tell you to calculate. So when you click on the calculate, the enter again, then you're going to have these values that you're having here. You're going to have these values that you have. You're going to have the S bar, the median, the number of data points you're having, so on and so forth, and you're good to go. Okay. The same examples are here. The same examples that you're having are here. So go through them. And I have a video posted online for you to also watch. I'll choose the calculator to do this. Okay, so it's very simple. Okay, so the same thing, calculate the mean, the median, just go through the same process and you're good to go. Okay, but here's the aspect that may need some kind of attention. So here we've been given the data frequency table, and we want to calculate the median, the mean, and the mode from it. So the mode, you can see the mode because the mode is the number with the highest frequency. So here the mode is what? 1, because 1 came in 4 times out of all the data points. So the mode is what? 1. But how do we calculate the mean and the median? Note that, so we have to find the sample median from this data frequency table. So the median we are saying that is the middle part of our data. So we can rewrite the data frequency table to our original data set. So 0 came in 1, so we're going to write 0 once. 1 came in 4, we're going to write 1 4 times. 2 came in 3 times, we're going to write 2 3 times. 3 came in 1, 4 also came in 1. So we rewrote all these data points, and I wanted to find the middle part. So we count, realize that the data points are what? Are 10, and it is an even data, and this data has been arranged from the smallest to the highest. That's the most important thing. It should be arranged from smallest to highest. Then since it's an even number of data sets, then there are 2 numbers in the middle. Add those 2 numbers together and divide by 2. So we had 1.5 to be the median. And how do we also calculate? Using the same frequency without going to the stress of rewriting it back. Then we are saying that if you have the sigma f, your total number of frequency, to be 10, then since you want the middle part, then we are saying that divide, if it is even, just divide by 2. So 10 divided by 2, we are going to have the 5th and the 6th position. We're going to have the 5th and the 6th position. So you have the 5th, add 1 to it, you're going to have 5th and 6th position. So now you start adding your frequencies. So we have 1 plus 4, which gives us 5. So we have the 5th position, but you have to go to the 6th position. But the 6th position comes in with what? With the 3, the frequency, and this 3 corresponds to 2. So you're going to have 1 and 2. So you add those two together and divide by 2. So it will be 1 plus 2, then you divide by 2, giving you 1.5. But if it is odd, like 11, then you have to add 1 to 11. Then it makes 12, then you divide by 2. So you're going to get the 6th position. It's a position. The 6th one is not the actual median, but it's a position in the data set. So you start adding your frequency again. Where is the 6th position in our data set? So you start adding the frequencies until you reach the 6th. So it will be 1th plus 4th. So you have 5th. Then you where can I find the 6th position? Then you can locate that with the S. Then you are going to get your median. Okay, in case you don't understand this, you can let me know. Maybe I can go through for you once again. The same thing applies to the stem and leaf diagram. So we have 8 data points. This is an even number of points. And note that this has been arranged from highest to lowest. So since we have the stem and leaf plot, then the middle part will be what? The 40th and the what? And the 41st position. Since it is an even number, we have the 40th and we have the 41st what position. So you start counting the leaves. So now forget about the stem, count the leaves. Which one of them is the 40th and the 41st what position? So we realize that we have 3 and 4 here to be what? The 40th and the 41st what position, and all of them correspond to the stem of what? 7. So it implies that 73 and 74 are what? The 40th and the 41st position. Add these two numbers together and divide by 2. You're going to have 73.5, and you are good to go. You are good to go. Okay, so a random sample of employees at Acme Corporation resulted in the following data for averages annual. Okay, so now we want to determine the center of our data points. But looking at these data points, you realize that there is a number that is far from each of what? These data points. If you are to use the mean to determine the sample, the center of our data, then we have the mean far away from each of what? Of these data. So we realize that the mean is 47, which is far from even from 25, and this can't be the center of our data. So we ask ourselves, why do we have more than one measure of the center of the data set of a data set? So when the data set contains outliers, the mean is no longer reliable. So we will use the median as the measure of the center in that situation. Okay, so median, the mean wouldn't be a correct measure to get the center of our data. Then the sample median will be the best one. So you can use your calculator to get the sample median. So always, if you have a data point far from each of these data points, do not use the mean as a measure to locate your center of your data. Use the median to locate the center of your data. And you can do so by using the calculator, or you can also do so using normal calculations. Then you are good to go. Okay, so we are saying that based on these measures of central tendencies, we want to know how our data is being skewed or is being symmetric. So if your mean is greater than your median, then you're saying that the data is right skewed. If it is less than the median, then it is left skewed. And if it is equal to the median, then it's symmetric. Then we have our data being centered, whereas that's normally what distributed data. Okay, so we have symmetric, that's a bell shape. It looks like a bell shape. And examples of symmetric or normal distribution, these are examples. We have the left skewed, we have the right skewed data. Okay, so these are some kind of examples that you can see. Okay, and we have a data set for which everyone is of equal size, of equal length. So no one is above each other, and that one is the uniform data. So you can have a data where we have two modes, just as I mentioned earlier on. So that's the bimodal data. Okay, so these are some examples that you can see. Okay, so this ends the lecture for section 1, 2.1 through 2.2. Okay, in case you have questions after watching this video, do not hesitate to email me. Thank you very much and have a wonderful weekend.